Hello and welcome everyone. In this particular section of video, I am talking about the termination process in the replication of the DNA in prokaryotes. So, while talking about the replication of DNA in prokaryotes, we know that the DNA of the bacteria or E. coli is in rounded form, right? So, what happens is the replication fork in the oric, this is oric, that is origin of replication. The replication fork will be started, the replication bubble will be formed here, and the synthesis will take place from both the side of the replication fork, from this direction also and from this direction also, right? So what happens is, after the synthesis of DNA, there will be helicase enzyme in both the side. Helicase enzyme will be there in both the side, but if the both will come and they will collide, what will happen? Right? If they will both come and they will collide at some point of time, there might be an accident, right? So to avoid this accident, what it does is, there is a termination sequence. In that, there is a termination site, there is a 10 termination sequence. There is a termination site. Within that termination site, there is 10 termination sequence. 1, 2, 3, 4, 5, 6, 7, 8, 9, 10. Within the termination site, this is a termination site. Within the termination site, there is a 10 termination sequence, and each sequence is facing the one direction. The 5 is facing one direction and another 5 is facing another direction. Alright. So what happens is, there is another protein known as TUS. TUS protein is termination utilization site protein. This protein will be binding above the sequence, termination sequence. So when the DNA synthesis will take place, when the DNA synthesis will occur, then this protein, the TUS protein, will be having two sides. One is permissive and another is non-permissive. Why is the site known as permissive and non-permissive is because the permissive site will allow the helicase to enter. If the helicase is somewhere here, for example, and it is going with the replication, then this will not cause any kind of hindrance, it will go smoothly. Alright, but non-permissive site will not allow the helicase to go in. Alright, but the non-permissive site will not allow the helicase to move. Alright, so what happens, helicase will come and enter here and it will stop somewhere here. Right, it can enter this part and it will stop somewhere here. From this side also helicase will come, it can enter this part and it will be stopping somewhere here, because it will not be able to go this side and this is also not able to go by on this. So what happened? They will meet up at a point, right? From this side also it is coming and from this side also it will coming, and they will stop at a point because they are not allowed to go further, isn't it? So at this point what happens? The replication will be terminated, right? From this side also 2 strand is coming. 2 strand is getting synthesized, and here also 2 strand is getting synthesized. So at the end what they will do is, they will form this kind of structure. They will form this kind of structure, isn't it? Out here they will form somewhat this kind of structure, because from this side also it is coming and from this side also coming, and it will be terminated somewhere here both, and then they will form this kind of structure, right? So after forming this kind of structure, what happens is this is known as catenance. This kind of structure is known as catenance, and this kind of structure will be what happens at one point. If I'll remove it, see, this is like this. If I'll cut at this portion, if I'll make a cut at this portion, then what happen? It will, so for example, if it is like this, if I am making a cut in this portion, then this part will be removed and they will settle individually. So this cut is done by topoisomerase 4 plus recombinase. Recombinase plus topoisomerase 4 will initiate a cut here, and now what happens is this 2 will be 2 individual DNA, right? So let us recap the thing once more. During the termination process, what happens is there is the origin of replication, and from the origin of replication, the replication will proceed from both the side of the replication fork, and it will come at the site of termination. In the termination site, there are 10 termination sequence, 5 termination sequence in one direction and another 5 in another direction. They are named as JGEPC-ADEHI. Alright, and within that termination sequence, there is a TUS protein known as terminator utilization site protein. These protein will bind above the termination sequence in each side, and these protein, they have a two end. One is permissive end and another is non-permissive end. When the helicase enzyme will pass through the permissive end, then there will be no hindrance, there will be no blocking in the way of the helicase enzyme. But as soon as the enzyme try to pass through the non-permissive end, the enzyme will be blocked then and there. The activity of enzyme will be stopped then and there. In the same way, from the opposite direction also, helicase can come through the permissive end, but it cannot move through the non-permissive end. So what happens is there will be a point at which both the helicase and helicase enzyme from both the side will be meeting one another, but they will not go further beyond that because there is a non-permissive site of the TUS protein. So at this point, what happens? The DNA, newly synthesized DNA also, they form a catenance with the parent DNA, right? At this point, the newly formed DNA will form catenance with the parent DNA, and this catenance is broken by topoisomerase 4 and the recombinase at one point, and then they are separated and then they are again sealed. Alright, this was only the process of termination. I hope you like the video. If you like my video, just hit the like button and subscribe to my channel and share it with your friends. Thank you.